Mr. Kelly, before we get started, I'd just like you to know that it's very cold and bright where I am located.
Hey, Mr. Creswell, how you doing?
Great, thank you.
Yeah, every day is a great day.
Yes.
Now, we're going to study parabolas a little bit today. So let's remember what parabolas kind of look like a U or an upside down U or even a sideways U or the other way U.
Those look more like
And
C's, but
there are
okay.
lots and lots of different things that we know about parabolas, and we're going to use those in order to make sketches of parabolas. We know kind of what they look like looking at all of their properties. So I'm going to start with the definition of a parabola. A parabola is the set of all points in a plane that are equidistant from. What does equidistant mean?
Equidistant means the same distance, or the same distance
Yeah. So it's the set of all points in a plane that are equidistant from a given point and a given line. We just happen to call the given point a focus point, and we call the given line directrix. All right, so Mr. Creswell, will you talk about some of the other features of a parabola?
So there's some other parts of a parabola. First is the axis of symmetry. The axis of symmetry is the line that cuts the parabola in half. There's the vertex. The vertex is the point located halfway between the locus and the focus and the directrix and the lattice rectum.
I think we're going to call the lattice rectum an LR, so we don't get all excited about the word rectum in there. LR. All right. Now there are a bunch of properties of
the lattice rectum is the distance from A to B through the focus, perpendicular to the axis of symmetry.
These parabolas, and I think I would probably pause the video at this point and copy this thing down. Maybe you want to copy this down as well somewhere. So pause and do that. All right, welcome back. Now, there are a couple different things we need to look at before we go into some examples. This column right here is for equations that start with y equals, and then there's some number, and in a parentheses squared, and inside this parentheses is x plus or minus another number, plus another number on the end. Now notice it's y equals. If it's y equals first, the graph's going to open up or down. Up or down. Now this whole set is for graphs that open right and left, and it starts with an equation that's got an x equals. So the first thing I do is identify which one of those parts of the chart I want to use.
X or Y.
So our first example starts with an x equals 1/3. Now, I think x equals 1/3, we're going to use this column of notes and none of that. So we're just going to scribble that out for the moment. Let's see if we can figure out A, H, and K. So now A is the number right in front of the parentheses. So that's 1/3. 1/3. And H is down here on the end. And so H in this case is down here on the end. It's a 5. All right. Mr. Creswell, will you talk about how to find K?
K is this number right here. So in our case, it would be a 4, but we need to change the sign on it. So it's actually a -4.
All right, very cool. So now the axis of symmetry is going to be at y equals k. So it's a line at y equals, in our case, k was -4. All right, will you talk about the vertex, sir?
The vertex is the point at h comma k, so it's going to be at 5 comma -4.
All right, very cool. Now, the focus gets a little bit crazy here because it's a set of points. And so we're going to go something, comma, something else. And the comma something else is comma k. So it's going to be comma -4. But figuring out what h plus 1/4a usually causes some pain. So it's h, which is 5, plus 1/4 times a. And in our case, a is 1/3. So that's going to be 5 plus 1/4 times 1/3 is 4/3. And what do?
Flip it and multiply.
Yeah. So this is 5 plus 3/4 or 5 3/4. All right. Mr. Creswell is going to talk to you about the directrix here.
Okay, the directrix is at h minus 1 over 4a instead of h plus 1 over 4a. So instead of taking 5 plus 3/4, we're going to take 5 minus 3/4. That puts us at 4 and 1/4 for the directrix. X equals 4 1/4 for the directrix.
Yeah, all right. So the direction of opening. Direction of opening, is it going to open to the right or to the left, sir?
Well, to the right, because a is greater than 0.
Yeah, I agree. It's going to open to the right. And the length of LR, I believe that is the absolute value of 1 over A, which is 1 over 1/3, which is the absolute value of 3, because we have to flip it and multiply, which is 3. So the LR is 3. Let's see if we can make a graph out of this. Now, our vertex was at 5, -4. So we'll go 5, -4. Right there is our vertex. And we know it's going to open to the right. So the thing is going to shoot from the vertex and shoot out like that. Where is the focus point? Well, it's at 5 3/4, comma, -4. So 5 3/4, comma, -4 is right there. The length of the LR is 3. So we have to come up 1.5. So here's
Which is half of 3.
1.5, and go down 1.5. So that gives us an LR equal to 3. And then we simply kind of connect the dots. La 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 la. All right, sir. And will you put the directrix on?
Yeah, the
there
directrix
for
we
us?
said was at x equals 4 1/4, so that's kind of right in like that.
All right, very good. We got the first one done. Let's try one more example, but this time we're going to have it go with the y equals here. So we're going to use this set of instructions, and we'll just scribble those out so that we don't get us too confused. All right, A is 1/8. Oh, that looks really bad. And H, H is in here now, so H is a 3. Like Mr. Creswell said, you change the sign. And then K is the 6. All right, I'll let you take the axis of symmetry.
The axis
sir.
of symmetry is just x equals h, which is x equals 3.
Very cool. And now the vertex is at h, comma k. So 3, comma 6. The focus point, oh, that's always the tricky one. So let's see, it's something, comma, something else. And it's h first. And I'm going to let you take it this time, sir.
Okay, so k plus 1 over 4a. I'm going to pause you, Mr. Kelly. K equals 1 over, k plus 1 over 4a. So that's going to be 6. I'll do my best here. This is going to be 6 plus 1 over 4a. Well, I think that's 4 times 1/8. And when this all shakes out, it's going to be 6 plus 2, which I think is just 8. So, whoa! There's an 8. You have to kind of use your imagination, but there, we should have it at 8 here. So I will try and draw that in. There we go. All right. Go ahead, Mr. Kelly. Now he's awkwardly waiting for me. Now you may go, Mr. Kelly. We got it. Go ahead.
Very cool. Very cool. Okay, now the directrix is going to be a k minus that number. So let's see, it's at y equals, and I think it was 6 minus 2, so that's at 4. Direction of the opening, which way, sir? Yep, I agree. And the length of the LR is 1 divided by 1/8, absolute value, so that is 8. All right, so our focus point is at 3, 8. 3, 8. In fact, I'm going to let you just graph the rest of this thing.
Oh, okay, so we got the focus at 3, 8, and then we set our vertex is at 3, 6. So that should be down here, 3, 6. I think there's the vertex. And the length of our LR, that tells us a lot, actually. What did we figure out? Was it 8? So that means the width here of the parabola is 8. So from the focus, I'm going to go over 4. 1, 2, 3, 4 in that direction, and 1, 2, 3, 4 in that direction, and kind of fa la 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 my way in here. So there's the parabola. All right, and so there's the parabola, and then we should draw in the directrix, which is at y equals 4. So we'll draw that in here too. So make it so I can write here at y equals 4. So that's where our directrix is. And that's it. That's all there is to it, graphing parabolas.